have is acceleration. And we know that in general, we start with position. Derivative of position is velocity. And the derivative of velocity is the acceleration. So we have to do our antiderivative twice here. So working backwards, this is our acceleration, so the next step would be velocity. What's the antiderivative of 10?
0. Wait, shoot. No, it's 10.
And the antiderivative of 30t? And what else do you need?
Plus C.
Okay. So we need to figure out C. That's what this information is for. So V is 0. If we plug in a 0 for everything, that has to equal -5. So my actual velocity function is 10t minus 15t squared minus 5. Then we need acceleration. So working back, or not acceleration, position, sorry. Antiderivative of velocity is position. So the antiderivative of 10t would be 5t squared. Antiderivative of 15t squared would be 5t cubed. Antiderivative of 5 is 5t plus c. But we...
You said position is antiderivative of first derivative? Or, wait.
Yeah, so it goes... The derivative of position is velocity. And the second derivative is acceleration. So we started down here. So we do the antiderivative, that gave us velocity. Antiderivative again gave you position. Alright, so now we have to find our C. We know that when t is 0, this has to equal 5. So the actual position function is 5t squared minus 5t cubed minus 5t plus 5. And you could reorder those terms if you wanted, but it's not required. Okay, so we are asked to write this as a definite integral. So this is just the definition. When you're doing that, the limit of the sum, that just turns into the integral symbol. Where are we integrating from? Starting at 0, ending at 3. Then this part. Each of your x sub i's, when we have an integral, we don't have x sub I, we just have x, right? So this would just be x cubed minus 3x squared plus 1. And change in x, what do we replace that with? Dx. Anytime you have an integral, you have to have that dx at the end. We didn't even have to calculate it, so we're done. Going okay? 28. We are asked to evaluate. Okay, anytime we've had had an absolute value all year, we have to first rewrite the problem without it. So to do that, we need to know what makes this equal 0. So 3x equals 6, that means x is 2. So we're going to integrate from -3 to 2, and then from 2 to 3.
So the absolute value always has to.
All right, if you plug in a number between -3 and 2, so if you put in a 0, is this positive or negative? Negative. So the absolute value would make it positive. So it does the opposite. So it's the opposite of this 3x minus 6. If you plug in something between 2 and 3, this is positive, so the absolute value doesn't change it. So now we integrate. We have a negative, and you could distribute that negative if you want. Antiderivative of 3x would be 3/2 x squared. Antiderivative of 6 would be 6x. Antiderivative of 3x is 3/2 x squared. Antiderivative of 6, 6x. So if you plug in a 2, 2 squared is 4, divided by 2 is 2, times 3 is 6, 12, put in a -3. Mess up on the calculations on 1. We'd have 27 over 2 minus 18 minus 12. Then, if I just do this, my 6 plus 6 is 12, my 18 is dropped, it's 27 plus 13. I had a negative on one of those the first time I did it. I just couldn't see it, so I had to work it over. There we go. Sorry that took me longer than it should have. Had a moment, I guess. All right. Next question. We had 32. So section 5.5, we are into the substitution stuff. Good notation is critical to being successful on these problems. So we always have to decide what to let your u be. Because I have to rewrite this integral so it doesn't have any x's. And the reason I have to do that is because it's a quotient. I have no way of writing this without a quotient, so I have no other option. We can't do the quotient rule in reverse. So you take that inside, and that is going to be our u. So my u is going to be the 5 plus 2 sine 3x. So that part becomes like the square root of u, or u to the 1/2. Then you need to find the derivative of this. So the derivative of 5 goes away. 2, derivative of sine is cosine 3x times the derivative of the inside. So you would get 6 cosine of 3x, and this gets a dx. We only want the cosine of 3x and the dx part. We don't want that 6, so we divide that over. So that whole part gets replaced with a 1/6 du. So what we really have here is the integral of 1/6 u to the -1/2 du. So then we can do the antiderivative, add 1 to the power, reciprocal in front, so that would be a 2 times 1/6 is 1/3 plus c. Since we don't have anything to plug in, we just have to rewrite this at the end so it doesn't have the u. So u was 5 plus 2 sine 3x. We have that plus c on the end. 33. Looks like we're working out all of these substitution problems. Okay, this problem could actually be done a couple ways. If you really wanted, you could multiply out the top and reduce it, but that's probably a little more work than we want to go through. And so we could do it with a substitution. Since that top, the 1 plus x to the fourth, or 1 plus the square root of x, that has a fourth power, so I'm going to pick that for my u. So du, derivative of 1 is 0. Square root of x, that's x to the 1/2, so that'd be 1/2 x to the -1/2, and that gets a dx. The square root of x on the bottom, that's the same thing as x to the -1/2. So I want the -1/2 and my dx. I don't want this coefficient, so we can multiply by 2. When you work this integral, one thing you have to watch, these limits match my x value. So you either have to change them now or go back to x at the end. I usually just change them. So I need to find out what u is. So if x is 1, 1 plus the square root of 1, so 1 plus 1 is 2. If x is 4, 1 plus the square root of 4, so 1 plus 2 is 3. Okay, this inside part is u, so that's u to the 4th. This, all that I circled in red, gets replaced with the 2 du. So we can do this antiderivative. The 2 would just come out in front. Antiderivative of u to the 4th would be 1/5 u to the 5th. We don't need the plus c because we're going to go ahead and evaluate. And if you work that out, you get 422 over 5. Is that okay? We have the integral from 0 to the square root of pi of t times the sine of t squared over 2 dt. So u is your inside. So that's my t squared over 2. Du. So the 2 would come down, so it would be 2t over 2, which is just t, and that gets a dt. So the t and the dt get replaced with this. Yes?
How doesn't the 2 choose to
Okay. Like right here, why do, because 1 is an exponent and 1 is a denominator. This is the same thing as 1/2 times t squared. So if we evaluate, remember this 0 and the square root of pi, those are my t values. If I'm switching to u, I need u values here. So if I put in a 0, 0 squared is 0 times a half is 0. If I put in a square root of pi, square root of pi squared is pi times a half, do pi over 2. then we have the sine of u, and the t dt just became d. Antiderivative of sine, so that would be negative cosine from 0 to pi over 2. So that's negative cosine of pi over 2 minus cosine of 0. We get positive 1. Are we okay with those things? So 35. I want you to first draw me a picture, then find the area. It would be helpful to know where these things meet if I'm going to draw a picture, so we can set them equal to one another. Add that over, so 2x squared equals 8. So x squared is 4. Square root plus or minus, so x is positive and negative 2. Okay, so now we need our graph. We're only going to have to go between negative 2 and 2. So if I put a negative 2 in, negative 2 squared is 4. 2 squared is 4. Put in 0, 0 squared is 0. So that's the first one. This one, if you put in negative 2 and 2, you get the same point. If we put in 0, we get out 8. So this is the little region I'm looking at. We need the area enclosed. So when we integrate, we have to do a starting and a stopping, and we already found that. So we're going from negative 2 to positive 2. These are x's, so I want to use all x's here. You have to do the top minus the bottom. So which one's on top? Minus the x squared. So we're integrating from negative 2 to 2 of 8 minus 2x squared. So the antiderivative of 8 is 8x minus 2/3 x cubed. Put in 2. How would you know if you did that wrong? You would have a negative at the end, so you would know that you had them flipped, which means you wouldn't have to rework the whole problem. You would just need to make sure that you made it positive for your final answer. All right, so we've hit all of the questions you guys brought up today. Is there anything else that I haven't? So we went to volume. Here is our function. And I gave you an interval. So we already have some pretty big clues. We know these are x values, so everything's going to be in terms of x. I asked you to draw the picture. So we only have to look at it from 1 to 3. So if you put in a 1, 1 cubed plus 1 squared is 2. Put in a 3. 3 cubed is 27, plus 3 squared is 9. So that gives us 36. So we're going to have a pretty big value here. Can I just not make my graph accurate? You guys care? I don't really want to count all the way to 36 on mine. So let's just. So, rough sketch, we know it's all the way up here, right? So we've got some kind of curve. If I rotate that around the x-axis, so think of it first as a reflection over the x, So then we are spinning this thing. So it's going to look something like that. When you do volume, you have starting and stopping. What you're integrating is the area of a cross section. Okay, since this is just spinning, my cross section is the circle. How do you find the area of a circle? Pi r squared. So my radius is my function. Okay, some of you have gotten into trouble on these by trying to integrate on this stuff. FOIL it out first. So that would give us x to the 6th plus 2x to the 5th plus x to the 4th dx. So then the antiderivative would be 1/7 x to the 7th plus 2/6, so 1/3 x to the 6th plus 1/5 x to the 5th from 1 to 3. And this one did not work out pretty. You had to probably grab a calculator to evaluate it. Something like that. Okay, so we have so we need to figure out where these things meet. Do you think it would be easier to solve for x or for y here? It's easier to get x equals, I think. So we could, let's get y by itself. So let's subtract over the x and the 5 and divide by 12. So y, I said one thing and I did another, didn't I? We said solve for x.
Is y easy?
No, it's not. So x is -12y minus 5. Okay, so now both of these are x equals. So let's set them equal to one another. Okay, it's a quadratic, so we need to have it equal to 0. So we have to do box method. So we need two things that multiply to 20, add to 12. Be a 10 and a 2. So we get 2y1, 2y5. Set those equal to 0, so we get y to be -1/2 and -5/2. Okay, so those are where these things meet. If you plug a -1/2 in here, -1/2 squared is 1/4 times 4 is 1. So when x is 1, y is -1/2. This one, that would be 25 over 4, so x would be 25. So it's not going to be a real nice one again. So that first little piece, we're getting kind of this type. If I plug it into the other one, if I put in a 1/2, x is 1. We have those same 2 points. So if you put in something in the middle, so maybe you plugged in a y equals 2, then you get -24 minus 5. So we are getting, basically we have a line and this parabola looking thing. And since I'm not taking the time to draw my graph entirely to scale, something like that. Okay, really rough sketch there. So when we set this up, we have y values, go small to large. We are just doing the area when we integrate with respect to x, we do top minus bottom. When we do it with y, we do right minus left. Again, if you flip them, all you have to do is throw a negative on the end. So the curve on the right is this line. So that was the negative 12y minus 5. Curve on the left was my parabola-looking thing, so my 4y squared. So antiderivative, 6y squared minus 5y minus 4/3 y cubed. Once again, these are not nice, pretty numbers, so you do have to probably pick up your calculator or take a little time working it out. But I want to make sure I go over a few other things, so I'm not going to spend a lot of time on that. You guys know how to do that. You plug the negative 1/2 in, and you plug the negative 5/2 in and subtract those. Anything else before I do just some additional review?
Can you do 30 real quick, please?
So, fundamental theorem of calculus to find the derivative of this. So, fundamental theorem of calculus talks about how a derivative and an antiderivative are opposites of one another. So this is the integral. If you really wanted, you could integrate this, get your answer, and then take the derivative. But the fundamental theorem tells us if you're going to do that, if you go from a constant to a variable, you could just plug that variable in. So that would be a sine squared x plus 1 cubed. Then you have to do the chain rule, so times the derivative of sine x. So the derivative of sine is cosine x. And that's all we would need there. So the fundamental theorem problems are pretty easy, but only if you remember what you're doing. You're just plugging in that variable. I mean, remember it has to go from a constant up to a variable, so if it had went from sine x to 1, you would have to do a negative. All right, so I made some notes of some things that we maybe struggled with a little bit, some of the older stuff. If I said find the differential of y equals the natural log of 4 plus 3t cubed. Okay, differential means find dy. If I just did the derivative of y would be dy dx. How do you do the derivative of a natural log? One over your argument. We'd have to do chain rule times derivative of the inside is 27t squared. I guess I really shouldn't be doing dx, should I? This should be a dt, because I use t for my variable here. Okay, so now all we have to do is get dy by itself. You could multiply this and make it 27t squared over 4 plus 3t cubed. And you just multiply over your dt. So that's your differential. It's just basically your derivative. But you move that dt or dx over to the other side.
So we never have to plug in.
And have you evaluate anything?
Where did you get the 27 t squared?
Derivative of the inside, chain rule. Other questions? Next question I have for you is can I just plug in my 0 here? No. The top is going to what? 0 is 1, 4 minus 4 is 0, over 0. 0 over 0, what's that? Yeah, that's an indeterminate form, so we need to do loc tap. So derivative of the top, derivative of e to a power is still e to that power. We have to do chain one. So the 5 comes down, so 5 times 4 gives me 20, e to the 5t. Minus derivative of 4 is just 0, so that goes away. Derivative of t is 1. So locale is derivative of the top over derivative of the bottom. Then we can plug in. We get 20 times e to the 0. So it's just 20 times 1, or 20. Make sure you look over roles and mean value theorem for tomorrow, know those conditions. Look over the summation rules, like for adding up I squared, I cubed, those rules. So I know we have those on our study guide somewhere. I don't even remember where now though. But make sure you know those summation pieces. Let's look at this one. What do we have to do here? Figure out what makes the inside 0. If x equals 2. So then you're going to integrate from 0 to 2 and from 2 to 10. If you put in something between 0 and 2, like a 1, that's positive, so the absolute value doesn't change it. If you put in something between 2 and 10, that's a negative, so we have to do the opposite, so -4 plus 2x. Do I need to work it from here, or do you? We're running short on time, but I just want to make sure you know how to set this up. Can you guys work it from that point? Do you remember your summation rules for the i's and things, or do I need to do one?
Yeah, because you go over it.
Yeah. So if I said, and since you won't have a calculator on the final, you probably would just have to set it up, not actually work it out. So if I said find the sum from 1 to 8 of, let's just do I cubed plus I squared minus I plus 3. What's the I cubed rule? N squared times n plus 1 squared over 4. So my n is 8, so it'd be 8 squared, n plus 1 would be 9 squared over 4. I, remember, is n times n plus 1 times 2n plus 1 over 6 minus I is n times n plus 1 over 2. And how do you add up a constant? You take, multiply it by n, so just 3 times 8. So that one had all 4. We did constants, and then things to the first, second, and third powers. All right. Is that okay? I had a fundamental theorem of calculus problem on here, but we just did one, so are we okay with it? I have 3 minutes. What if I said a word problem? What should we do here? Draw a picture. We have a rectangle. We're not going to put fence along the school, so one of these sides I don't need any fence on. These would be the same, this would be different. If I want the largest area, I'm trying to maximize my area. Area is, bless you, length times width. But we can't do the derivative when I have two variables in here. So, we know we have 175 meters of fence. So, that's your perimeter. If you add all of these up, it equals 175. So, y is 175 minus 2x. Get 175x minus 2x squared. Then if I want to maximize or minimize, what do we have to do? Anytime I want the maximum or minimum of something? Derivative. So that would be 175 minus 4x equals 0. You want the derivative to equal 0. And divide by 4. And what do we get? 57.5. And then you would write the sentence. Make sure you look over your related rates problems. There'll be one of those on the portion you're taking tomorrow. So those were like